Together. So, how about Jacob? Jacob, what did you find for physical change? Or I think we might have already done this, but let's write it down here. Not example, definition first. Properties change. Composition does not. So what I want for my first example is something that I did yesterday. One of the things maybe with the paper, or with the boiling water, or when I burnt the sugar. I want something that's a physical change with what I did yesterday. Danielle? So we would say ripping is a physical change. Okay, now it doesn't have to be from yesterday. It can be what you found or something that you thought of. I need a volunteer for another physical change. Go ahead, Ryan.
Weathering.
What do you mean by weathering?
Like, for example, rain changes like houses and stuff.
So maybe eroding?
Oh, eroding, my bad.
Eroding, I like that. Okay. I think weathering might not be a bad term at all for that. And Colin?
Ice melting.
I can't hear you, sorry.
Ice melting.
Okay, so melting. You've completely changed what it looks like for sure, but why is it that physical, not chemical, Colin?
Because it's still the same.
Yeah, it's still the same chemical, just a new state of matter. We did not change composition when we melt. Same thing with boiling. Same thing with sublimating, which you'll learn about. How about a definition of chemical change, Hannah?
For chemical change, I said change that produces matter with a different composition than the original matter.
So I just abbreviate that. Composition becomes different or changes. I just say composition changes. So my first example I want from something with yesterday at the end. What's something that we saw a chemical change yesterday?
Smoking.
What smoking? The water boiling? And what did we do to that sugar? Burning, okay. I like it. Alright, Colin, give me another, not Colin, sorry. Yeah, Colin. I have two Collins, so Carter. Yeah. Alright, I get it. So, Colin, give me another chemical change. It doesn't have to be from yesterday, then. Sugar burning. Melting, be careful. And let me show you the difference. I'm glad you brought that up. And you don't have to write this down. But H2O, when it has an S in parentheses down below, that stands for solid. And if you're writing a chemical equation, you have an arrow to show that it's changing. And in this case, we add a triangle because we're adding heat. The triangle stands for heat in a chemical equation. You guys will learn that later. So what happens is it becomes H2O with a little L symbol for liquid. Okay. So my formula here is what? H2O. My formula over here is what? H2O. I didn't change the composition, just the different states of matter. But here's what happens with sugar. It doesn't melt. Okay? It didn't melt. What it does, glucose here, you add heat to it, it becomes carbon with a symbol like that. And what you saw with the vapor there was actually H2O gas, G. Okay. So what's my formula before I changed it? Yeah, and I got to do a better job. Go ahead, Ryan. And Carolina, what's my formula or formulas over here?
B plus H2O.
Yeah, so it changed. The composition changed. Okay. So do you see the difference there when we break it down like that? All right. And not everything melts. You ever see a piece of wood melt or think about a piece of wood melting? You add heat and sooner or later it's going to burn. It's not ever going to melt though. Not everything will actually melt. Right, so burning is one. Another chemical change. What do we think? I know one the book has for sure because the other classes had it. What do we have? What did you find, Ilya? Yeah, an example of a chemical change. You guys were all done and wrapped up, so I'm assuming you got something. Yeah. Yeah. It definitely would be one. How about another one, Hannah?
For chemical change?
Yeah.
Would it be color? Or would that be like?
But that's a property. Color's not changing.
Yeah.
I need to think of a word for something changing. Yeah, go ahead, Jack.
Rust.
Rust. And here's what rust looks like in the formula. You don't have to write this down. That stands for iron right there. Iron is a metal that rusts very easily. What it does is it reacts with the oxygen that's in the atmosphere. And the rust that you see is actually this formula. So I had Fe, I had O2, and my new thing is Fe2O3. So the composition changed. Yes, sir.
When you really studied becoming a chemistry teacher, did you have to learn
All the elements?
yeah, not well, like, I mean, I can understand that, but like, did you have to learn what everything turns into after it makes it?
Do you want me to be completely honest with you? I was never taught how to teach chemistry. I was taught how to teach social studies, but I was never really taught how to teach chemistry. And in fact, you know, the last time I took real chemistry, I was a little older than you, right around 21, 22. So I pretty much had to reteach. I mean, I learned it, but I had to reteach myself before teaching my first year as I went along. So, yeah. Right now what I'm doing is I'm reading, I used to read history, now I add science and stuff to what I read so I can help answer questions. Alright, intensive property. We got three there. Does anybody have another chemical change that they'd like to share? You guys, talkative but not sharing much with me. Anybody think of another chemical change? Come on, there's a lot of cool things with chemical changes. Go ahead. Decomposition or rotting, definitely. Exploding. There we go. This is more like it. Yes. Baking soda and vinegar. Yes. Baking soda and vinegar. So what is happening there? That is an example of something. I mean, it's just recombining and forming gas. That is an example of a chemical change. I just don't know how we could phrase it simply. Huh? Is evaporating a physical or chemical change? Why physical?
Changes state.
Changes.
Like if you were talking about the gas evaporating,
There, and here's the thing. You got to be careful because evaporating is only used to describe change of state. We could say a chemical change is something producing gas, but changing from a solid or a liquid into gas is that's the term evaporation. So to me, yeah, you're right the way you're thinking about it. It's just we only use that evaporation when that water boils. Okay. Fusion, yeah, fusion. I like it, and we'll actually do a little short unit on nuclear chemistry. I taught it last year, not the year before. I like teaching. It's kind of cool. Definitely. All right. So that's good. That's what I want from you guys. We raised our hands. You guys were giving me stuff. Oh, Benson is like in his glory when it's like that. Eddie, intensive property definition, please.
A property that depends on the amount of matter in a sample.
Yeah, go ahead with intensive then. I know what you did.
A property that depends on the type of matter in a sample, not the amount of matter.
Okay, so what I'm going to say is I'm going to focus on the difference. Does not depend on the amount, because what's different about extensive, Eddie? Yeah, that one does depend on the amount, exactly. So extensive property does not depend on amount. Intensive does not depend on amount. Extensive does depend on amounts. That's the difference. Yep. All right. So Nakia, you got one intensive property for me? Go ahead. Hardness. Okay. So what she's saying is this desk has this hardness, right? If I have just a little piece of the desk, is it still going to be that hard? If I have a bigger desk of the same stuff, is it going to be just as hard? Yeah. Diamonds are the hardest thing there is that can cut anything. And they're the hardest thing. They cut anything because of their hardness. It's actually a technical term. So a small diamond's going to cut glass, and also a big diamond. So it did not depend on the size. So yes, hardness is definitely. How about another one? I'm back. How about Skylar? Did you find anything for intensive property? Do you know what that means? When you hit it and pound it thin, it changes its shape. So if you got metals are very malleable. If you got a big piece of metal, you can pound it thin, just like a small piece of metal. I like the term malleable. Love it. Love that term. What do you got for me, Samantha? Texture? Luster. Do you know what that means? Yeah, that's exactly what it is. Luster is shininess. So a little piece of something shiny and a big piece is also going to be shiny. Okay. Anybody else? Go ahead. Density. All right. Can I come back to you? I want to talk about it. And you're right. But here's the thing. Texture is one. So density, we're actually going to talk about density for a day or two here. Let's think about things floating right now with density. Okay, like an ice cube is less dense than liquid water, so it floats, right? So a big piece of ice is also going to float in water, like a small piece of ice will? Yeah. So density is an example of an intensive property. It is an example. Right. How about extensive property? What about something that does depend on the size? Go ahead, Jacob. Mass is one. And when you guys think mass, the same thing, you think weight. And we could have the proper definition. Weight has to do with gravity, but think of it this way. I take up a certain amount of, no, I don't take up space, that's volume, but I also have a certain amount of matter in me, my mass. Okay? When I go on the moon and I step on a scale, do I have the same weight? No, you guys all know that because of gravity I don't have the same weight. But I didn't lose any of my matter, did I? So, correct term is mass, but that's really just scientists being a little full of themselves, because where do we do work? Here on Earth, where there's more gravity than the moon. So my feeling is, who cares? But we use the word mass, okay? And that's the difference, has to do with gravity. Yes, sir?
So since you said the mass is different than weight, could we put weight as another example?
No, we're going to keep them as the same right now. What's another example of, go ahead. Volume. How much space I take up. Yep. Mass and volume are different. Okay. And how about one more? We had one over here, Hannah.
Height.
Height, or some sort of length measurement. Some sort of measuring a length. Obviously matters. Surface area. I'm going to stop right now because I want you guys to have the last bit of class to yourselves. What you're going to do is you're going to take your element paper, and with the people at your table group, you're going to share what you found, but what I want you to do is this. This is where I need your attention. I want one person to get a separate sheet of paper and be a secretary, because I want you guys to take a look at each person's two properties and classify those properties as either extensive or intensive, and then whether they're physical or chemical properties. Does that make sense what I'm asking you to do?
Yeah.
And just one person write it on a separate sheet of paper.